Hi, hello, welcome back students of grade 11. In this video, you are going to see concepts related to chapter motion in a straight line. Here I am going to cover all the concepts what are present in this chapter and 5 lectures it will take to complete this entire chapter. This is your first lecture where you are going to see few concepts like what is meant by motion, different types of branches in mechanics, what is rest, motion, and two concepts, distance as well as displacement. These are the concepts which you are going to see in this lecture. And not only these concepts, you see what are the concepts which are present in this chapter, theory, what are the derivations. In every chapter, I'm going to cover every chapter in your class 11 at the same time class 12. This channel is more than enough for your reference, where you are going to get 100% knowledge on all the concepts which are present in the chapter and every numerical problem related to every concept and NCERT exercise solutions of the chapter and objective type questions which will be helpful for practicing for your examinations, something like IIT, Advanced, Mains, NEET, NDA, etc. And all the competitive section questions, all the previous year questions of this JEE Advanced, Mains, NEET also will be covered in every chapter. So follow this channel regularly and every video will be uploaded on time. And take one reference book. You can follow NCERT textbook, and I'm going to refer one book, that is S.L. Arora. This is the reference book. You can take it where you are going to get 100% of knowledge, where I'm going to deal all the concepts from this reference books. Okay, without wasting our time, let us start this lecture. First, this chapter is starting with the concept mechanics. What is meant by mechanics? What are its various sub-branches we have? You see, mechanics is a branch of physics that deals with the condition of rest or motion of the material object. In mechanics, you are going to learn about objects which are at rest, at the same time objects which are in motion. Now, if you are going to study about objects which are at rest, this is known as statics. Here you can see it's a branch of mechanics that deals with the study of objects at rest or in equilibrium. If any object is at rest, we can call it as equilibrium also. In further chapters, you are going to see this word. And even when they are under action of several forces, different forces might be acting. For example, you see this will be an object where some 10 Newton force will be acting from this side. From this side, 10 Newton force will be acting. When both forces are equal, this body will be at rest. So equilibrium, state of equilibrium we can call, or state of rest we can call. So regarding all the concepts we can see in further chapters, no need to worry. So in this chapter, we are going to see only basics of mechanics. Then when body is in motion, again, there are two sub-branches. First one is kinematics. Second one is dynamics. See, when body is in motion, why we need two branches, kinematics and dynamics? Here, kinematics is a branch of physics or branch of mechanics which deals with study of motion of an object without considering the cause of motion. So, for example, one ball will be present and that ball will be in motion. Why that ball is in motion? How much force is applied? Who kicked that ball? And what are the external forces acting on the object? These conditions we are not going to see. We are going to see only object which will be in motion, and we don't want its cause of motion. If you neglect or if you are not studying about the cause of motion, then it is kinematics. While coming to dynamics, here it is a branch of mechanics that deals with study of motion of object taking into considering the cause of motion. So there will be a body. Here you are going to study who applied force, how much amount of force is applied, in which direction or which angle force is applied, what are the external agencies acting on the body. So all these conditions we are going to study. If you are going to study the conditions along with motion, it is known as dynamics. And if you are not studying the cause of motion, it is known as kinematics. So there are three branches: statics, kinematics, and dynamics. So after that, next topic is rest. What is meant by rest? At the same time, motion. You see, whenever you want to study, if you want, you can pause this video and you can write the definition and you can go ahead. Then rest. What is meant by rest? An object is said to be at rest if it does not change its position with respect to surrounding. You see, surrounding as well as time. Consider there is a tree and one ball is present. Now, ball is at position A. Now time has started, t is equal to 0 second, t is equal to 1 second, t is equal to second, third second, fourth second, fifth second, and so on it will be going on. Though time is increasing, there is no change in its position. Such type of conditions we are calling it as rest. If there is no change in its position at the same time. So time is increasing, position there is no change, we can call that state as rest. Now, what is meant by motion? An object is said to be in motion if it changes its position with respect to surrounding at the same time. Now, consider there is a tree which we can call it as reference. Why we are taking tree? Not only tree, anything you can take. We can call it as reference. So this is reference point from where motion can be calculated or measured. Okay, consider there is a car. Now, time t is equal to 0 second. Now car is moving. When time is equal to 1, car came here. When time is equal to 2, car came here. Time is equal to 3. Like that, car will be changing its position with respect to time as well as surrounding. That is known as motion. So here we have definitions for rest and motion. Then moving to next topic, rest and motion are relative terms. So what is that rest and motion are relative terms? Here, consider there will be a person A. Here we have person B, person C. Now what is that term? State and motion are relative terms. According to A, this body B will be in motion. Now according to this C, this person B might be at rest. So how it is possible? At the same time, for one observer, he will be in motion. For another observer, observer C, this person B will be at rest. How is that possible? So one example, let us see. Okay, consider person B and C both are traveling in a bus or in a car. Here. So here we have a car where person B and person C both are traveling in a car. Now this body will have some speed. It will be moving with some speed. And this person B is sitting beside this person C. Now according to person C, if he is observing, he is just sitting beside only, no? So that person will be at rest. According to C, B person is at rest because he is sitting beside only. Though time is changing, position is changing, that car might go to Hyderabad, it can go to Delhi, it can go to Mumbai. But beside this C, B is sitting. So that according to C, B is at rest. Now, consider person A who is standing outside on the road. According to this A, this B person is in motion. So A will tell this B person is in motion according to him, according to his observation. And according to observation of C, B will be at rest. Like that, we can tell both rest and motion are relative terms relative to each other. Now, they're asking another question, you see. Can a body exist in a state of absolute rest or of absolute motion? Is that possible? See, to talk about rest or motion, as I told, we need some reference point. Reference. Here, there is no fixed reference point. Absolutely fixed space has chosen for the reference point. Here, there is no possibility of absolute reference point, so that there is no possibility of absolute rest or absolute motion. It is not possible. Next. Concept of a point object. In physics, many chapters you will be coming across the concept of point object. What is a point object? If the position of an object changes by distance much greater than its own size. Here, if a body is in motion. When body is in motion, size of the body is very, very, very less than distance. In other sense, distance traveled by the body is very, very, very greater than size of the body. Then that body is considered as point object. For example, consider one bus. This is a bus which is traveling from Kashmir to Kanyakumari. Okay, what will be the length of this bus? Maybe 2 meter or 3 meter, maybe 5 meter long bus will be traveling from Kashmir to Kanyakumari. What is the distance from Kashmir to Kanyakumari? Something around 2300 kilometer. So 2 meter is size of the bus. 2000 kilometer, 2300 kilometer is distance traveled. So when compared to distance, size of the body is very, 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 very minute. Now this body, this bus can be considered as point object. Like that, you need to understand that concept. Then moving to fourth concept in this chapter, motion in one dimension, two dimension, and three dimension. What is meant by motion in one dimension? The motion of an object is said to be one dimension if only one of the three coordinates specifying the position. Means we know this is the origin. We have x-axis, y-axis, z-axis. If the motion is observed only in one dimension, that is towards x-axis, let us consider. So consider this is the reference point O. Body is at A. Now, body is moving from A to B, or it can move from B to A, or it can go from B to O or A to O. It is moving only on x-axis. Here only we are taking the reference. So this is the origin. This is x-axis, where we can make it as a distance 1, 2, 3, 4, maybe in kilometers you can take. Body is starting from horizon. It is going to P point, which is 2 kilometers away. Again from P to Q distance it is going like a 4 kilometer. Again from Q to P it can come back. From P to O it can come back. Everything which is happening only on x-axis. So this type of motion we are considering it as motion in one dimension because it is going only towards x-axis. Next, examples: motion of train along a straight track. So from railway station, train will start and it will be moving forward in only one dimension. Motion of freely falling body, consider this is ground, and here at certain height from the tower, if you drop a ball, that ball falls down only in one dimension, only one axis. Either you take x-axis, either you take y-axis, either z-axis, only in one axis, motion should be observed. Now, what is meant by two-dimensional motion? The motion of an object is said to be two-dimensional if only two of the three coordinates specifying its position change with time. So in three axes, x-axis, y-axis, z-axis, you have to see motion only in two axes. For example, consider this is x-axis and y-axis. First, position of an object may be here. How to inform the position, how to tell the position? We can make it as 2, 3. Means from x-axis, distance is 2. From y-axis, distance is 3. For example, this is 1, this is 2. This is 1, 2, this is 2. So this is 2, this is 3. Let us take. So from here, 2, from here, 3. So this is the position of an object. Now after some time, position of an object might have come to here. So which we can call it as 4, 4. So consider this is 3, 4, and here we have 4. If you take distance from x-axis 4 units, distance from y-axis 4 units, this is the change. Now You are informing the position. You are telling about the body's position by taking two axes into consideration, x-axis as well as y-axis. From x-axis 2 unit distance, from y-axis 3 unit distance, like that you are telling now. So such type of motion we are calling it as two-dimensional motion. Two-dimensional motion which we can see in a plane. One-dimensional motion, it is also known as motion in straight line. Motion in straight line. Two-dimensional motion we can call motion in a plane. 2D motions are plane. Example, motion of planet around the sun. Number 2, a car moving along zigzag path on level road. So these are the examples for 2D motion. While coming to third type of motion, three-dimensional motion. In one-dimensional motion, only one axis will be coming into act. In two-dimensional motion, two axes. And in three-dimensional motion, all three axes we are taking, like x-axis, y-axis, z-axis. You see, if you want to mention about this point A, we are telling like x1, y1, z1. Means from x-axis, x1 distance or x1 units, from y-axis, y1 units, from z-axis, z1 units. So we are taking all three axes so that this motion is known as three-dimensional motion. Examples like a kite flying on a windy day. So consider there will be a kite. Now from here, from any reference point, you can take x-axis, y-axis as well as z-axis. All three axes can be observed. Next, motion of an aeroplane in the space. There will be horizontal distance, vertical distance from a reference point. Everything will be considered. So there are three types of motions we can observe: one-dimensional motion, two-dimensional motion, three-dimensional motion. One-dimensional motion will be observed in straight line. Two-dimensional motion will be observed in plane. Three-dimensional motion will be observed in space. So one-dimensional motion in straight line, two-dimensional motion in plane, three-dimensional motion will be observed in space. So these are the things you need to understand. Moving to next concept, distance. What is meant by distance? Distinguish between the terms distance and displacement. Okay. Distance, or you can call it as path length. It is the length of the actual path traversed by a body between initial and final positions. Consider this is initial point A, this is final point B. How we can go from A to B? It is not compulsory that you need to go in a straight line. Sometimes here there will be another point C, another point D. Body might go from A to C first, next C to D, after that D to B. So total path traveled by a body, consider from A to B it is 2 kilometer distance, from C to D it is 3 kilometer distance, and D to B again 2 kilometer distance. If they ask you what is the total distance traveled by a body, total distance we can call it as AC. We can take it as AC plus CD plus DB. So AC value is 2 kilometer, CD value 3 kilometer, DB value 2 kilometer. Total 7 kilometer is the distance traveled by a body. So distance nothing but total path traveled. For example, here also body is traveling first A to C and then it is traveling from C to B. So total distance is A to C plus C to B. Like that you can take it. So definition for the distance is total length or total path traveled by a body. Next, distance is always scalar quantity because it has only magnitude. There is no direction, and always it has to be taken positive. So distance values will be either in positive or distance value can be 0, but distance will never be negative. We cannot find any negative distance. And while coming to SI unit, it is meter, means answers. Whenever you are solving the problem, you have to write distance is equal to either 1 meter, distance is equal to 2 meters, distance is equal to 10 meters. Like that, you have to represent SI unit. So every physical quantity is equal to numerical value into SI unit. So this distance is the physical quantity. 2 is numerical value. Meter is SI unit. Like the D is equal to 2 meter, 5 meter, 10 meter, 8.5 meter, like that you can mention. Next concept is displacement. What is meant by displacement? Displacement of an object is change in position of an object in a fixed direction, or it is the shortest path measured in the direction from initial point to final point. You see, while coming to displacement, we have another definition. A straight line drawn between initial and final points. If you draw just a straight line between initial and final point, then that line or that path is known as displacement. Here you see, in this previous example, body has traveled from A to C, again C to D, again D to B. Here, what is the starting point, initial point? A is the initial point. B is final point. Instead of drawing like this, if I draw a straight line from A to B, this straight line is nothing but displacement. Total path is distance. Shortest path is displacement. So, distance is nothing but total path. Displacement is nothing but shortest path. That shortest path always it will be in straight line. This distance, it can be in any shape. Any shape. It can be straight line, it can be curve, anything. Next, while coming to displacement, displacement can be positive, it can be negative, it can be zero also. And SI unit of displacement is equal to distance, that is meter. Distance also SI unit is meter. Displacement also SI unit is meter. So distance is represented with the letter D. Displacement represented with the letter small s. When we are moving forward, whenever we are finding the term distance or displacement, both will be mentioned with the letter S. Don't get confused. Then its CGS unit is also there for distance and displacement. CGS unit is centimeter, but 99.9% we are using SI units only, so that we have to take meters. Then after displacement, there are few characteristics are there displacement. Okay, why we need to read all these concepts? As I told you, if you are aware of every theory or all concepts, now it will be very useful for you to understand the questions which they are asking in your competitive exams. So whatever it may be, the numerical problems, numericals or objectives in your school-based examinations or JEE, NEET, all these examinations, it will be very helpful and useful if you know every theory and concept, so that never miss these classes. Every class will be in order. Lecture 1, lecture 2, lecture 3, like that it will be in order. And all these lectures, try to cover it so that every concept will be in your hands. Okay, next. What are the characteristics of displacement? Number 1, displacement has units of length. So every time displacement is nothing but length. Distance traveled by the body, which is in straight line, nothing but displacement, and its unit is length unit, that is meter. Second characteristic, the displacement of an object can be positive, negative, or zero. So displacement values, it can be positive, displacements can be negative, displacement can be zero also. Next example is, when an object moves towards right in time t1 to t2, its displacement is positive. For example, the O is the reference point, body is at A. Now, body is moving from A to B, which is towards your right hand side. So, distance, what we can tell, we can call this one distance or displacement as a positive, because consider this is reference point. This point may be 1 meter, this point may be 2 meter. If you ask how much displacement occurred in the body, we can tell 1 to 2, that is 1 meter displacement, that is 2 minus 1, nothing but 1 meter. Okay, next. When object moves to left in time from T1 to T2, its displacement is negative. For example, this is the reference point. Consider body is at A at time T or T1. T1 is equal to 0 second, let us consider. And body is moving from A to B like this. And time becomes 1 second. And in 1 second, how much distance it is traveling, how much displacement is happening in the sense you can tell. Maybe here it may be 1 meter, it may be 2 meter. You can tell displacement is equal to minus 1 meter. Now displacement has become negative also. So as we discussed, displacement can be positive, displacement can be negative if it is moving towards left hand side in the graph. That graph, you know, this is reference point, this is x-axis, this is x dash axis. On x-axis, all the points, all the values will be in positive, and on x dash axis, it will be negative, minus 1, minus 2, minus 3. If body is going towards right hand side, it is positive direction and values will be positive. If it is moving towards left hand side, it is negative direction. So value will be in negative terms. Next, when body remains stationary or it moves first towards right and then equal distance towards left, its displacement is 0. Means consider body is at A. First it is moving towards B. After some time from B, body is coming to A. Now A is only initial point and A is also final point. Initial point is also A. Final point is also A. If initial and final points are same, if initial and final points are same, then displacement value is 0. Like that we should consider. Then displacement is not dependent on choice of the origin of the position coordinates. So it can be, if you are moving, for example, in this graph you see, this is the reference point O and body is at A. And what is the distance from O to A? In this graph it is mentioned as x1. Now body is moving from A to B. If body is moving from A to B, consider it has moved from the origin, distance is x2. Now if you shift this origin, consider origin is not here, consider origin is here, new origin or new reference point, O reference point, you can consider this O dash as new reference point. Now this distance displacement, it won't change. You see, from O dash to A, it can be x1 dash, and O dash to B, it can be x2 dash. Okay, there is no change in its value. That is what it is telling. Now, x2 minus x1 will be equal to x2 dash minus x1 dash, like that. Next, fourth point, the actual distance traveled by an object in given time interval is greater than or equal to magnitude of the displacement. So it can be greater, actual distance traveled by an object in given time interval, it can be greater than or equal to the magnitude. So in the same time, it can travel more time or more distance or less distance also. Number 5. The displacement of an object between 2 points is the unique path that takes the body from initial to final position. This is initial position. This is final position. Always displacement, we will take it in a straight line only, not in any curved manner. Number 6, displacement of an object between two positions does not give any information regarding the shape of the actual path followed. See, for example, body is traveling like this, or something like this. Body is traveling from A to B, then C, then D, after that to E. So what path it is taking, what is the geometrical figure, it will not tell. Only it will talk about initial point and final point and straight line. That's it. Then 7th point, the magnitude of the displacement. So what is meant by magnitude? Magnitude is nothing but value, just numerical value. So numerical value, magnitude of the displacement of an object between 2 points gives the shortest distance between these positions. So as I said, for example, A to B, 2 meter, B2C 2 meter, here 2 meter, here 2 meter, here 2 meter. So what is the total distance? Total distance traveled by the body 2 plus 2 4 plus 2 6 plus 2 8 plus 2 10. Total distance traveled is 10 meter. But what is the displacement value? Initial point is A, final point is E. Total displacement from A to E, it is only 2 meter. So it will not talk about in which path it is traveling at the same time. It will not give the total distance traveled. It will talk only regarding displacement, that is shortest distance between these points, shortest distance between initial and final points. Last one, displacement is a vector quantity because it has both magnitude as well as direction. So regarding all these, we are going to study in further classes. So in this class, there is only a basics. So we have studied only basics regarding what is meant by mechanics, what are the two different branches in mechanics, statics, kinematics, and dynamics. These are the three branches. If a body is not changing its position with respect to time, it is rest. If a body is changing, it is motion. And then what is meant by point object, and what are the three types of motions you can observe: 1D, 2D, and 3D, and distance, definition, displacement, definition, and SI units we have studied, and characteristics of displacement. These are the introduction concepts, and this PDF also will be available in description link. You can download this PDF for your further reference. And then in next class, we are going to see speed, types of speed, and formulas, velocity, different types of velocities, and uniform and non-uniform motion. We are going to cover these concepts in our next lecture. So subscribe to this YouTube channel. At the same time, you can share these videos to your friends who are going to start 11th class, and you are going to get all the concepts in my lecture, like concepts, theories, derivations, numericals, everything. Don't miss out any videos. All videos will be in sequence and everything will be in some order, and every lecture try to cover it so that you will gain 100% of knowledge in all the concepts, which will be helpful for you to solve all the numerical problems and objective problems, which will be helpful in advanced mains and NEET examinations. So, and if required, you can buy this book SL Aurora, where I'm taking all the concepts from this reference book only. So you can have a reference book, or if you are not buying a reference book, these videos are more than enough to gain every point, every concept knowledge. And this PDF also will be in your description link. So you can like, subscribe, and share to your friends. And we'll meet in next lecture. Until then, bye. Have a nice day.